Hey everyone, welcome back to the channel. Today I'll show you how to convert a single 2D image into a dynamic video with eye-catching effects. Whether it's for animations, cartoon shorts, or your own projects, this technique will bring your image to life. Let's get started. Open Create Studio and create a new file. Set the resolution as per your preference. I have set it to 1920 by 1080. I created a background using AI with Media Place. You can use your preferred tool or a high-quality stock image to achieve a similar result. In this tutorial, we will use God rays to enhance the visual appeal of our video. Using Blender 3D, we will create animated God rays, also known as light shafts. Beams of light that stream through gaps, adding a dramatic and cinematic effect. Integrating these into our scene will make the animation feel more immersive, atmospheric, and visually striking. Don't worry, I'll guide you through each step in detail, ensuring that even if you're new to Blender, you can achieve stunning results with ease. Drag the first background image onto the timeline. This is a video of God rays that I previously created, but in this tutorial we'll create a new one from scratch using Blender. Don't worry if you're new to Blender, I'll guide you step by step on how to create simple God rays and integrate them into your project. So let's open Blender and get started. I am using Blender 4.3.2 version for this tutorial. To download Blender, visit the official website at blender.org and click on the download option. In the drop-down menu, you'll see two options, Installer and Portable Zip. If you don't want to install Blender, simply download the portable zip file, extract it, and run the application directly. I have installed Blender 4.3.2 version. If you want the LTS version, which stands for long-term support, click on LTS and download the available version from there. When Blender opens, a splash screen appears displaying your recent files. On the left side, you'll see options like New File and Open File. To close this window, simply click anywhere on the viewport outside the splash screen. I have set Blender to a dark theme, but if your interface looks different, don't worry. The options remain the same, only the theme is dark. This is a beginner-friendly tutorial, so I will explain everything in detail. This way, artists and viewers who are new to Blender will find it easy to follow and understand. I have positioned the screencast display in the bottom left corner. This will show all mouse clicks and keyboard inputs in real time, making it easier to follow along. Delete the default 3D cube and light from the viewport. Simply select the 3D cube and the light, then press Delete on your keyboard. Alternatively, hold down Shift to select both objects and delete them together. At this stage, I won't be diving into viewport navigation and other options in detail. Instead, simply follow along with the steps I provide. Rest assured, I'll be creating comprehensive Blender tutorials very soon to cover these aspects in depth. To begin, navigate to the Add menu, select Light, and then choose Spot from the submenu. A spotlight will be added to the 3D viewport. Next, click on View, navigate to Viewpoint, and select Front. This will adjust the viewport to display the front view. Use the mouse scroll wheel to zoom in and out smoothly. Select the Move tool from the toolbox as demonstrated in the video, and carefully position the light accordingly. On the right side of the viewport, you'll find a hand icon for panning and a magnifying glass icon for zooming. Use these tools to navigate the viewport efficiently. Once the light is in place, switch to the Rotate tool located just below the Move tool and adjust the light's orientation as demonstrated in the video. To deselect any tool or 3D object, simply click on the empty space within the viewport. Now select the camera and press N on your keyboard. This will open a Properties panel on the right side, displaying various settings and attributes related to the selected object or view. These options allow for precise adjustments, ensuring optimal control over your scene. Click on the Item tab in the Properties panel. Set the location and rotation values to 0. This will reset the camera's position and alignment, placing it precisely at the world origin with all transform and rotation properties set to 0. Now select the camera and navigate to the Properties panel. Precisely set the X-axis rotation to 90 degrees to align the camera for an optimal view. Select the light and move it along the X-axis, as demonstrated in the video. Select the camera, navigate to the View menu, and choose Top from the viewpoint options to achieve a precise top-down perspective. You can also select objects from the outliner. This part is called the outliner. Here all the elements are visible. If there are many assets in the file, it helps to select from the outliner. Select the camera and move it along the Y-axis, as demonstrated in the video. Remember, when adjusting along the Y-axis, the movement remains constrained to a straight line. The same principle applies when manipulating objects along other axes for precise control. To divide the viewport into two sections, hover your cursor over the corner of the viewport until it changes to a crosshair icon. Then, click and drag to split the area, as demonstrated in the video. You can adjust the split by dragging in your desired direction, either horizontally or vertically. To toggle the sidebar in Blender, press the N key on your keyboard. This action will either display or hide the sidebar on the right side of the 3D viewport, allowing you to customize your workspace as needed. To switch to the active camera view in Blender, navigate to the View menu, select Cameras, and then choose Active Camera. This allows you to view your scene from the perspective of the active camera, facilitating precise composition and alignment. Select the camera from the outliner panel on the right side and adjust its position. You'll observe the camera's real-time movement within the viewport. To switch to a front view, navigate to the View menu, select Viewpoint, and then choose Front. As demonstrated in the video, reposition the camera accordingly. The orange bordered area in the viewport indicates the camera's frame. Only the content within this boundary will be rendered. To disable environment lighting in Blender, navigate to the World Properties tab in the Properties editor, represented by a red earth icon. In the Surface section, click on the color field next to Color and set it to black. Then adjust the strength value to 0. This ensures that the environment does not emit any light, allowing for complete control over scene illumination. To access additional options in Blender's interface, such as the viewport shading settings represented by the shading icon, hover your cursor over the header. Click and hold the middle mouse button until the cursor changes to a double-sided arrow. Then to the left to reveal any hidden elements as demonstrated in the video. At the end, you will find the shading options. These settings allow us to render the image directly in the viewport. Select the last icon labeled Rendered to activate real-time rendering mode as shown in the video. The rendered output currently appears black because the world background color is set to black with its strength at 0, resulting in no environmental illumination. To generate God rays, we need to introduce volume scatter, which will enhance the scene with proper lighting and create a volumetric light effect. Before proceeding, we need to set the appropriate render engine. Navigate to the Properties panel, click on the topmost render icon, and select Eevee from the Render Engine drop-down menu. This ensures optimal real-time rendering for our scene. To add volumetric scatter, navigate to the Editor Type dropdown, located in the header on the left side of the viewport, and select Shader Editor. If the camera viewport shifts accidentally, simply reselect the viewport and press 0 on the numpad to reset it to the active camera view. To hide the Properties panel in the Shader Editor, press N on your keyboard. Pressing N again will bring it back if needed. Click on the Use Nodes icon to enable node-based editing. You can use the middle mouse button to scroll and zoom in or out for better visibility. Next, switch from Object to World using the drop-down menu. Navigate to the Add menu, select Shader, and choose Volume Scatter from the list. This will add a new node, which should be positioned beneath the background node. Click and drag from the volume output of the volume scatter node to the volume input, represented by the green dot on the world output node, to establish the connection. To achieve the desired volumetric lighting effect, adjust the density value in the volume scatter node from 1 to 0.1. This modification reduces the medium's density, allowing light to scatter more effectively and creating the intended volumetric light effect. Next, select the light source in your scene, navigate to the Light Properties panel denoted by a bulb icon, and increase the power setting to enhance the light's intensity. The power parameter, measured in watts, directly influences the brightness of the light source. Adjust this value according to your scene's requirements to achieve the desired illumination, as demonstrated in the accompanying video. Click on the Editor Type drop-down menu and select 3D Viewport to switch back to the main workspace. This will restore the 3D view, allowing you to continue working on your scene with full control over object placement, lighting, and composition. Switch to the top view to refine the camera positioning. Navigate to the View menu, select Viewpoint, and choose Top to align the viewport accordingly. Now select the camera and adjust its position to match the reference shown in the image. This step ensures a clear framing of the scene. Camera positioning is an iterative process. We will fine-tune it further to achieve the optimal angle for the final composition. To precisely adjust the camera's position along both the X and Y axes simultaneously, select the small blue square located at the intersection of the X and Y handles in the viewport gizmo. This allows for smooth and controlled movement across the plane. making it easier to position the camera accurately within the scene. Switch to the top view for precise alignment. In the outliner, locate and select both the light and camera. Click on the eye icon to hide them from the viewport. To make them visible again, simply click on the eye icon once more. This helps maintain a clutter-free workspace while making adjustments to other elements in the scene. Navigate to the Add menu, select Mesh, and choose Circle. This will generate a circle in the viewport. With the circle selected, go to the Object menu located on the left side of the header and switch to Edit mode by selecting the first option. This allows for precise modifications to the circle's geometry, as demonstrated in the video. Located next to Edit mode, you will find three selection modes: Vertex Select, Edge Select, and Face Select. The first option, Vertex Select, allows manipulation of individual vertices. The second option, Edge Select, enables selection and editing of edges, while the third, Face Select, is used for modifying entire faces. For this step, select the second option, Edge Select, ensuring precise edge-based modifications to the geometry. If the edges of the selected circle are not fully highlighted, click and drag to select the entire circle with the mouse or simply press A on the keyboard to select all edges. Then, press F to fill the circle with polygons, converting the open edge loop into a complete surface for further modifications. Press T on the keyboard to toggle the toolbox visibility, allowing for a cleaner workspace while modeling. Pressing T again will bring it back if needed. While the circle's face is selected, press I on the keyboard to activate the Inset tool. This will create an inset polygon within the existing face, and a dotted line will appear between the cursor and the polygon. Move the mouse inward to adjust the inset size. Without clicking anywhere, press Shift+R to repeat the last inset action, further refining the shape. Follow the process demonstrated in the video. This technique enhances the resolution of the circle. If the face is not selected for any reason, choose the third option next to Edit mode to switch to Face Selection mode. I have previously provided detailed information about this option. With the circle selected and in Edit mode, switch to Face Selection mode. Then randomly select multiple faces resembling a dice pattern as demonstrated in the video. To select multiple faces, hold down the Shift key while clicking. The selection does not have to match the video exactly. You can choose the pattern as you see fit. These selected faces will be used to create holes in the mesh, allowing light to pass through and generating the volumetric lighting effect we will implement later. With the selected faces, press Delete on the keyboard and choose Faces from the Delete menu. This will remove the selected faces, creating holes in the mesh. These openings will allow light to pass through, contributing to the volumetric lighting effect that we will refine in the next steps. Now that the editing is complete, switch from Edit mode to Object mode to exit the editing phase. Next, switch to the front view for a better perspective. If your object is not visible, click on the viewport and press the Dot or Del key on the numpad to focus on it. If the circle is deselected, locate it in the outliner, select it, and repeat the same process to bring it into view. With the selected circular mesh, activate the Rotate tool from the toolbox and adjust its rotation as demonstrated in the video. Next, unhide the light source from the outliner. Utilize the Pan and Zoom tools to refine your viewport positioning, ensuring both the circle and the light source are clearly visible in the front view. Carefully position the circle as shown in the video. As you move it closer to the light source, you'll begin to see the volumetric lighting effect take shape. Activate the Scale tool, located beneath the Rotate tool in the toolbar. To maintain uniform proportions, use the central scaling handle, represented by the green box, for a universal scale adjustment. Avoid scaling along the X or Y axis individually, as this will distort the circular shape. This ensures the object retains its intended form and functions correctly within the scene. Take your time to precisely align the circle for the desired effect. Now let's render the volumetric effect we've created. Navigate to the top menu and click on Render, then select Render Image. This will initiate the rendering process, generating the final output with the applied volumetric lighting. Select the light source and adjust its intensity to achieve the desired illumination. Next, change its color to a warm orange tone to enhance the lighting effect. Remember to save your Blender file regularly to prevent any loss of progress. Select the light and duplicate it by pressing Shift+D, then drag it. Right-click immediately after dragging to lock it in place, then rotate the light as needed. Repeat this process to add another light and adjust its rotation accordingly. Once positioned, hide these new lights in the outliner until they are needed. Then, adjust the camera view to frame the scene accurately. Now let's animate the volumetric light. First, select the circle and ensure the transform panel is visible by pressing N on the keyboard. In the header, locate the Global Transform tab and open the dropdown. Switch from global to local for more precise control. Next, under the Transform panel, navigate to the Rotation section. From the Rotation Mode dropdown, select XZY Euler for accurate rotation adjustments. In Blender, transform orientations define how objects move and rotate. The global option follows the world's X, Y, and Z axes, while local moves the object relative to its own rotation. Normal aligns transformations to the surface direction, making it useful for editing geometry. Choosing the right orientation ensures precise control over positioning and animation adjustments. The timeline in Blender helps control animation playback and keyframe placement. Drag the playhead to frame 1 to set the starting point. Use the middle mouse button to pan and scroll to zoom in or out for better control. While the circle is selected, set the playhead at frame 1 on the timeline. In the Properties panel, ensure the Z rotation value is set to 0. If not, manually set it to 0. Now go to the Object menu in the header, navigate to Animation, and choose Insert Keyframe with Keying Set. In the dialog box that appears, select Rotation to add the first keyframe. Next, move the playhead to frame 140. In the Properties panel, set the Z-axis rotation to 360 and insert another keyframe, just like you did for the first keyframe. Set the end frame to 140 on the timeline to match the last keyframe of the animation. This ensures that only the animated portion will be rendered, preventing unnecessary frames and keeping the animation duration precise. Select the circle, drag to select both keyframes on the timeline, right-click, go to Interpolation mode and choose Linear. Select the light, go to the Properties panel and adjust the color to a warmer tone. Unhide both lights from the outliner, then select each one individually and set the same color for both to ensure uniform lighting. Now let's prepare for the final render, but first, verify a single frame output. In Render Properties, set the render engine to Eevee for real-time efficiency. Under Sampling, increase render samples to 128 if performance is a concern, lower it to 64. Navigate to the Render menu in the top bar and select Render Image. Analyze the output meticulously. If the lighting, colors, or overall look require refinement, fine-tune them now before proceeding to the full animation render. To render the final video, navigate to the Output Properties in the Properties panel. Scroll down to the Output section and click the folder icon. Create a new folder and name it as per your preference. Then, name your file and click Accept to confirm the save location. You can adjust the resolution here to match your desired output quality. The frame rate can also be modified to control the smoothness of the animation. Let's now move to Create Studio for the next step. Drag and drop the rendered video into Create Studio. I'm slightly increasing the image size, but you can adjust it as needed. Set the timing according to your preference and place the imported Godrays clip on top of the background layer. Play the video. You may notice it appears too fast, but don't worry, we'll fix this by adjusting the settings. Apply the clip speed effect from Effects and Components to the Godrays layer. For this tutorial, I rendered a 140 frame video, but you can slow it down by increasing the frame count in Blender before rendering. Select the Godrays layer, go to Properties and set the blend mode to lighten with an opacity of 30%. You can fine-tune the settings based on your scene. I'm adjusting the opacity to match the sunlight. Check the other blend mode options as well and apply what works best for the rest of the settings. Now duplicate the Godrays layer, change its blend mode to lighter, and set its opacity to 25%. If this additional layer isn't necessary for your scene, you can skip it. Select the background layer and apply color correction from Effects and Components. Adjust the settings as shown in the video. Next, create a rectangle and assign it the color specified in the video. Ensure this rectangle remains on the top layer, then set its blend mode to Overlay. Finally, apply Hue Rotation from Effects and Components and set the value to 317 or adjust it based on your scene. I applied the Sharpness effect to the background layer to fix the blurriness caused by image scaling. Now select both Godrays layers, right-click and choose Group. Duplicate the group and extend it to match the video length. Similarly, extend the rectangle layer until the end of the video to maintain a consistent effect throughout. Now select the butterfly from the studio and drag it onto the timeline. Keep the first layer unchanged and duplicate it. Apply position, rotation, and scale animations, ensuring all are set to linear. Adjust the movement, rotation, and scaling to match the animation style shown in the video. Download Fog 3 from Visual Effects in Studio and drag it onto the timeline as shown in the video. Position it over the scene to enhance the atmosphere. Then go to the Properties panel and set its blend mode to Screen for a seamless integration with the background. Adjust its opacity if needed to achieve the desired effect. With Visual Effects open in Studio, download Dust 7 and drag it onto the timeline. In the Properties panel, set its blend mode to lighten and adjust the opacity to 40% for a subtle effect. Next, duplicate the layer and extend it to match the entire video duration. Always ensure that the rectangle layer remains on top for a consistent overlay effect. Based on the video length, I have already animated the character. While the animation isn't perfect, it effectively serves the purpose of this tutorial. I have selected this character, but you can choose anyone you prefer. In a previous video, I explained how to create shadows and reflections. You can refer to that for details. In the next tutorial, I will cover the character's walk cycle animation along with shadows. To seamlessly integrate the character into the environment, a duplicate of the original character has been created and placed above the original character. The hard light blend mode has been applied from the Properties panel, with its opacity reduced to 30% to enhance the lighting effect. This adjustment helps the character interact naturally with the scene's lighting. Additionally, the Shadow Layers blend mode has been changed to soft light to create a more realistic and natural-looking shadow. These refinements ensure the character blends smoothly with the background while maintaining depth, contrast, and a polished final look. This completes our tutorial. I hope you found this process helpful in enhancing your animations and improving your workflow. Keep experimenting with different effects and settings to refine your skills. Thank you for watching, and I'll see you in the next tutorial with more exciting techniques.